Hello everyone and welcome back to Quadratics. So today's video we'll be focusing on this year's trial paper for Negeri Sembilan paper 2, and I will rate this paper's difficulty as 3.5 over 5, which is similar to paper 1, because I think that some of the questions are quite straightforward, but some of the questions need some time to process and to solve. Right? And I also noticed that the sub questions, so for example, which is not the exact question, which is something like question 9 part B and then part 2, those kind of questions also need a lot of time to solve. So I feel that the 2 hours and 30 minutes, I feel that it is not enough time to solve all of the questions. Right? But don't worry, so here I try my best to give the best tips for you to solve the questions faster. Okay, but the main aim of the video is to understand the questions first, and then also to understand how do we come up with the solution. Right? So that's the important thing for this video. Okay, so without wasting time, let's discuss this paper together. Question 1 focuses on quadratic functions, and here we have a quadratic graph, and in part A1 we need to express the range of values of P in terms of Q. So range of values here usually means our final answer, there would be inequalities. So inequalities meaning the less than and greater than. Okay. But from here, how do we get inequalities? Right, so let's observe the diagram, which is the only clue that we have. Right, so here this quadratic graph, it does not intersect the x-axis. Right, so we can relate back to one of the sections in this chapter, which helps us. It's a quantity that helps us to make a conclusion. What happens if the graph does not intersect the x-axis, does intersect the x-axis, and so on. And that quantity is called the discriminant, or the b squared minus 4ac. As we know, the b squared minus 4ac, there will be 3 cases, right? So one is greater than, equal, and less than 0, right? And these are the graphs that we see all the time. So if it's greater than 0, then intersect 2 points, equal to 0, 1 point, less than 0, no points, which is the case that we are seeing now. Right? So to start off with our working, we can use the inequality here, b squared minus 4ac less than 0. Right? And this is how we get the inequality. Alright? So now what we need to do is just to find the values of b, a, and c lah. Okay, so value of b would be the value of x, which is 2q, and a would be the value which is x squared, which is minus 1, and c would be the value that does not have x, which is negative 5, p plus 1. Right, and then we just simplify, and we need to make sure that p is on the left side. Right, so everything which is not p move to the right, and we move the negative 20 to the other side. But make sure, when we move negative 20 to the other side, we need to change the direction of the sign. Okay, and this will be our answer. For the next part, it says that we need to change the value of b to be negative 2q. So originally it was positive 2q. Now we need to change it to negative. Okay, and then we do sketch this new graph on this diagram. So first thing first, let's understand the values of a, b, and c from the quadratic function. Okay, to see what does each of the value represent. Okay, so b here actually helps us to determine where is the position of the minimum or maximum point. Okay, so for our question here is a maximum point lah. Okay, so now let's consider all the cases where we change b. Okay, but before that, I would like to let you all know is that b and a for this case works together. Right? So the first case is if a and b are both positive or negative, then the point should be on the left side of the y-axis. Okay, if it's not this case, then it's on the right side. If it's not both of these cases, which means if b is equal to 0, then it's on the y-axis. But now as we see here, the value of b, there are values. Alright, so for this one, we can ignore first lah. Okay, we just look at these two cases. So originally, both of the values, one is negative and one is positive. So the maximum point should be on the right side, as you see here. Alright, so now when we change 2q to become negative 2q, both have the same signs already. Both are negative. So the position of the maximum point should be on the left side, which is somewhere here. But before I draw the graph, we also need to consider the things that is represented by A and C, because the things represented by these two unknowns cannot change, because we only change B. Okay, so for A actually represents the shape meaning the width of the graph, right? So if you want to draw the new graph later, we must maintain the width of the original graph. It cannot be wider or narrower compared to this graph. It must be exactly the same. Okay, and for C represents the y-intercept. So as you see in this graph, the y-intercept is here. So when we draw the graph later, we also need to intersect the same point, okay, which is here. Right, so our graph will look something like this. As you see, the position of the maximum point goes to the left side of the y-axis. The shape does not change, meaning the width does not change. The y-intercept is the same, okay? Intersect at the same point. Okay, one last thing is, there is this axis of symmetry here, so it's Q originally, okay, because here is positive. So now we change to negative, we can just change our axis of symmetry to become negative, right? So here would be our axis of symmetry, which is x equals to negative Q. For part B, we have two different function graphs and we need to find the function for h of x, right? So this means, how do we change g of x to become h of x, right? So the first thing is, let's identify the differences, right? So the first noticeable difference is, this one is a smiley face, the other one is a sad face, so means it is upside down, right? The second one is, if you see the new graph here, it's much wider compared to the graph above. Okay, so this is the second difference. So now with these two differences, we need to identify whether it relates to A, B or C. For the first difference, if we see the shape of the graph, right, we know that if the graph is a smiley face, then the value of A is positive or greater than 0, as we see here. But if it's a sad face, then A is negative or A is less than 0. So we have found out the value of A already. So we can use this as an example. We change the value of 2 here, the positive 2, to become negative first. Alright? At least we change the A to become negative. Alright, so we have done this one. So the second thing is, it becomes wider. So this actually relates to A, right? Because in the previous part, we said that A helps us to control the shape of the graph, either become narrower or wider, right? So recall back when we change the value of A, if A changes in a way that is away from 0, meaning from 0 to 5, the graph becomes narrower, which is something like this. But this is not what we want, right? What we want is the opposite, which is we change the A to be closer to 0. So the graph becomes wider, which is something like this, right? The graph becomes wider, which is what we want. So for our answer, we can change the value of A here, which is negative 2, to be more closer to 0. So an example to become -1, and that will be our answer. Alright, but your answer may be different from mine, right? Because here in the question it says possible quadratic function. So it means there will be a lot of answers for this question, but you need to satisfy the only condition here, which is the value of a must be between -2 to 0. Right? If you achieved this condition, then technically you have your marks. Question 2 focuses on coordinate geometry. So here we have a straight line, and this point P actually divides or splits the line with this ratio 3 to 1. And in part A, we need to find the value of H and K, which is the coordinates of the 2 points here. Okay, so once we see a point which divides the line and is given the ratio, we can use one of the formulas in the formula sheet, which is this one. Okay, so this formula basically is to help us to find the point within the line if we are given the endpoints, which is, let's say, for example, A and B and the ratio. Right? But this time is like the other way around. So here we have the point that divides the line, and we need to find back the coordinates. Okay, so for the left side here, we should substitute the point that divides the line, which is point P. Okay, so left side should be H10. So there's a lot of students who make the mistake, which is they substitute the endpoints, which is A and B here. Okay, which is wrong here, so please prevent that. Right, and for the right side, you can use a commonly used technique, and I think school teachers will teach you all this as well, which is you place the ratios on the line and then you cross multiply. This is to prevent students to substitute wrongly when they are using this formula. Okay, so here for the n, I will usually take the ratio on the right side, which is the 1. Okay, so 1 multiply with -10 first, then I multiply 3 with 22, add them up together, and I divide with the addition of the two ratios, 3 plus 1. And for the y coordinates, same thing as well, it's just that I need to substitute the y coordinates here lah, which is k and 12, and then I simplify and I compare left side with left side, right side with right side, and then I can find the value of h and k, which is 14 and 4 respectively. For part B, we need to find the equation of the straight line which is perpendicular to AB and passes through point A. Alright, so to find equation of straight line, we need to have two things. One is the gradient and the other one is the point. Alright, so now it says it is perpendicular to AB, so let's find the gradient of AB first. Okay, so the formula for gradient is y1 minus y2, so let's say B is the first point, so 12 minus k, k is 4, right? And then I divide by x1, which is 22 minus -10. Right, then I simplify to get 1 over 4, and here it says perpendicular, so we need to use this formula, which is the multiplication of two perpendicular lines will be equal to -1. Right, so this 1 over 4 put inside here, find the value of m, which is -4. And then for the second thing we need to have is the point. So point, we can use point A because it passes through point A, so we can use the -10 and 4 here. Alright, and then we can use this y equals to mx plus c to help us find the y-intercept. Okay, so with the point here and the gradient here, we substitute inside, find the value of c, and then we can form our equation of straight line already. Okay, so our gradient here is -4, y-intercept is -36. For part C, we need to find the equation of locus for point Q if the distance from point B is 13 units. Right, so equation of locus, we have two cases. One is one fixed point and the other one is two fixed points. So if we see here, the only fixed point is just point B. Right, so we can go to the first fixed point case. So for the first fixed point case, left side is actually the distance formula. So we are just finding the distance from the point Q here to the fixed point B. Right, and then the right side will be our condition, because here it says the distance from Q to B must be 13 units. Alright, so for the x and y here, I will just remain because we don't know the coordinates for this moving point. Right, for the x1 and y1 will be our fixed points, fixed point B's coordinate, which is 22 and 12. Alright, so I minus them, square them, add them up together, and square root. And for the right side, you will need to put equals to 13. Right, so later on here will be just mathematical calculation lah. So the square root here, move to the other side to square the number, so it will be 169. And here the things inside the square root, we expand it out. And then for the next line, is just move everything to the left side and simplify. So this would be our answer. For question 3, focuses on system of equation, and here we have a curve equation and a straight line equation. So now we need to find the intersection points. So usually to solve this, we can use the substitution method, meaning use the more simplified equation and sub into the more complex equation. Alright, so there are two things I would like you all to know, which is the 4 significant figures. Okay, so this one later I'll explain when we find out our answers. And another thing is the intersection points, okay, the S at the back. So means we will get more than one answer. Right, so let's start off by rearranging this equation a bit, because I want the x to be on the left. Okay, reason is because I can just use this equation, substitute here by changing all the x. Okay, change all the x to become y, as you see here. Right, and then I just simplify the equation to get a quadratic equation. Right, so usually we can use the calculator and we type the numbers and then we can get our answers, right? But if you notice, when you type into the calculator, your answers will be either have decimals or square root. So when you see either one of these two things, we cannot just use the calculator. What we need to do is use the quadratic formula, okay? Because the answer is in decimals, not fractions or not a whole number. Okay, so we need to use this quadratic formula to help us. Alright, so what we need to do now is just finding the values of A, B, and C. Okay, so value of A will be 15, B will be negative 56, C will be 44. So this is how we substitute. Okay, so B changed to negative 56, and the A here will change to 15, C change to 44, and the A at the below will change to 15. Okay, and then we simplify, and then we split it into two versions. So one version is positive, the other version is negative, and then we just find the value of y. Right, so once we find the value of y, we can substitute back the simplified equation, okay, which is this one, to find the value of x. Okay, so now you can see that we have two sets of answers, right? So that's why here there is intersection points. Alright, then later on, and I think this one is also important, which is to write out your final answers in one sentence. Okay, so we can write the first set of answers and the second set of answers. Alright, so 4 significant figures, meaning 4 important digits to explain the value. Right, so for example here, the 1 here is very important, right? Because it's the biggest digit among all of the digits here. Right, so this will be considered as one important digit to explain the value. but we need another 3 supporting digits, right? So we will just take the 3 digits after this decimal point, 218. So in total, there will be 4 important digits, meaning 4 significant figures. Question 4 focuses on progressions, and here we have the first 3 terms of a geometric progression, right, which is these 3, and it says that the beta, okay, this symbol is called beta, B-E-T-A, cannot be minus 1, right? So in part 1, we need to find the value of beta. So to find this, we need to recall back the main characteristic for geometric progression, which is if you want to go from one number to the next number, we need to multiply or divide a value, right? So for example here, if you want to grow from beta minus 2 to beta plus 1 and then go to 2 beta plus 2, we always need to multiply the same value, which is known as the common ratio, or R, right? R is the common ratio that we see all the time. Okay, so now since we are multiplying the same value, which is R, so why not we form multiple equations that find R, right? So for example, if I take beta plus 1, to find R, I need to divide back the previous value, which is beta minus 2, right? Same goes to 2 beta plus 2. Then I divide with the previous value. So now we have 2 equations which finds the same value. Okay, but here we are finding beta, correct? So since these 2 equations are finding the same thing, so why not we use either one of the equation and substitute inside? Okay, so this means this part of R I can change to this part, and I can form an equation which is something like this to find the value of beta. Okay, so now here is just mathematical calculation. So what we can do is this denominator multiply here, this denominator multiply here. Okay, so cross multiply lah. Right, so once you simplify and move everything to the left side, you will get a quadratic equation, and then you can use the calculator, put the values inside, and find the 2 answers. So one is 5 and the other one is minus 1. Okay, so recall back, it says that beta cannot be minus 1, so this part we need to reject. Okay, and our value of beta is 5. And the second part, we need to check whether the sum to infinity exists or not for this progression. Right, so if you look into the formula sheet, there is one formula that explains the sum to infinity, but you can see at the back here, there is this condition. Okay, so front is the formula, this one is actually the condition to help us find the S infinity. Okay, so if let's say the R, okay, if I arrange this a bit, R is between -1 and 1, we can find a value for S infinity. But if it's not, let's say R is equals to 3, the sum to infinity either will be infinity or negative infinity, so means no answer. Alright, so now what we need to do is we need to calculate the value of R to see whether it satisfies this condition. Okay, so to find the value of R, very simple, we can use either one of the equations here. Let's say we choose this one, sub the value of beta to find R. Okay, so it's 2, so means it has failed to satisfy this condition. So here we can write a small conclusion. We can say that since R is not between -1 to 1, so the sum to infinity does not exist. The next part is a K-bar question, so let's go through this question slowly. Right, so here we have a plant, and it says that if we compare the height of the previous branch with the next branch will be shorter, and will be shorter by 5%. Right, so this means if we have the height of the first branch, and if we want to find the next one, we need to multiply the remaining 95%, or 0.95. right? Because here we have lost the 5%, so we have only the remaining 95% to find the height of the next branch. Okay, so since we are multiplying to get the height of the next branch, or meaning multiplying to find the next number, so this progression is a geometric progression, right? Because we are multiplying to get the next number. Okay, so in part 1, we need to find the height of the first branch, which is x, if the height of the whole plant is 201.95 and the plant has 8 branches. Okay, so in progressions, we have two kinds of formulas, right? One is Tn and the other one is Sn. So the main difference between these two is Sn will tackle those questions which involves total or sum. Tn does not, right? So here, go back to our question. 201.95 is the total height if the plant has 8 branches. Okay, so since this is the total height of 8 branches, we need to use Sn. Okay, so our n here, we can change it to 8, and then I can equate it with 201.95. Okay, so from the formula sheet, then we can find the formula of Sn for geometric progression. Okay, but here we have two different formulas. Okay, so the main difference is the first formula can be used if r is greater than 1. The other one would be r is less than 1. So we need to find the value of r first, which we have already found, which is the 0.95 here, right? So we need to use this one. So a is x as given here, right? And here will be 1 minus, then the r will be 0.95 and n will be 8. And here we divide by 1 minus r, which is 0.95, and I can move this part to the right side to find the value of x, which is 30. For the next part, it says that the plant continues to grow and we need to find the maximum number of twigs if the height of the smallest branch, meaning the last branch, is more than 80 cm. Right, so twigs are the things as you can see at the end of every branch. Okay, as we see here, these are all the twigs. Okay, and occurs at the end of every branch, and there will be 4 twigs. Okay, so to find the number of twigs, we need to find the number of branches first. Okay, so to find the number of total branches, we need to form a simple progression to see how do we find it. Okay, right, so I know it's not geometric progression, this is just a simple progression to help us understand how do we find the answer. Okay, so if we apply this condition into this progression here, so the smallest term or the last term would be 20. Okay, and if we find the value of n from Tn here, so n here is equals to 4. Okay, why this is important? Because the last term helps us to decide the total number of terms in the progression. Okay, so for example, 20 is the 4th term, so in total there are 4 terms. So if I apply it to this question, if 20 is the height of the last branch, so means this is the 4th branch, so means in total there are 4 branches. Okay, so last term helps us to find the total number of terms. So what we need to do is just using this Tn and apply it with this condition, and we find the value of n. Okay, as we see here. So this technique is actually the exact same technique when we are trying to solve the progression question in paper 1. Right? We also use inequality to find the last term that satisfies the criteria. Okay, so again, last term helps us to find the total number of terms. So in our case here, the last branch helps us to find the total number of branches. Alright, so here for the Tn, we can use the formula for geometric progression, which is arn minus 1. So a will be 30, r would be 0.95, and n minus 1, we remain it as it is, and we just move everything which is not n to the right side. Okay, and because we want to move the n minus 1 to the front, we need to multiply log for both sides. Okay, so we can pull the n minus 1 down, and we need to move this to the right side. So make sure, yeah, to change the direction of the sign, because this value is negative. Okay, you can plug it into a calculator, but this is a negative value. So values which are lesser than 1 for log is always negative. Alright, and then we simplify this thing, move negative 1 to the other side, then we will get n is less than 10.959. So this one, because n is an integer, right, not a decimal, not a fraction, so we need to find the smallest integer, the largest integer which is lesser than this value, which is 10 lah. So n equals to 10 means the last branch is the 10th branch, and means that we have in total 10 branches. Okay, so to find the number of twigs, we just multiply 4 to find out our answer. For question 5, focuses on trigonometric functions, and here for part A, we need to prove this equation, right? So what I will do is usually choose the side that is more complex, which is the right side lah. Okay, reason is because we can manipulate more things compared to the other side, which we only have one function, which is quite hard, right? So let's start off with the right side, and here the first step I will do is to change all the functions to become either sine or cos. Okay, even with the tan as well. So tan x, we know that it is sine x divided by cos x. So all the 6 functions that we have learned, all can change it to sine x and cos x, right? To able to help us to simplify the expressions here even easier. Okay, so for the secant x here, we know that it is the inverse of cos x, so we can change it to 1 over cos x, and since this one has become a fraction, so we need to make this to become a fraction as well. Okay, so the numerator and the denominator, we need to multiply cos x. Right, so it will be something like this. Okay, then later on, since we have the same denominators, we can combine the two fractions here. So here will become cos x. Okay, and this cos x, I can move it on top. Alright, and here there's a minus here. So the result would be 2 sine x cos x, and denominator would be 2 cos square x minus 1. Alright, so now there's not much to simplify, so let's go back to the equation that we need to prove. Okay, so here we have 2x. So this means we need to look at the formulas that has 2x. Alright, but just a side tip, actually if you do more exercises, you'll be able to familiarize this and this expression to a function already. Okay, so here we need to familiarize ourselves with the formulas. So for example, right, if you look at the formula sheet here, for 2 sine x cos x, you'll be able to link that, oh, this is sine 2x. 2 cos square x minus 1, you'll be able to link that, oh, this is cos 2x, instead of looking to the formula sheet and find the formulas. So I wish you can do more exercises on this, so you can easily match. Okay, 2 sine x cos x is sine 2x straight away. Okay, so this one will be sine 2x, this one will be cos 2x, and then if we use the result here, sine divided by cos is tan. So our answer would be tan 2x, and we are able to prove this equation. For part B, we are going to sketch this tangent graph, right? And we have 2 things to note here. So the first thing is the modulus. The second thing is the range that we're going to draw. So x must be between 0 until pi or 180 degrees, right? This could be a bit different with our graphs which are drawn previously, which is we will draw until 360 degrees, but now it's only half. So later, once we draw out the graph, then we can cut off the other half of the graph, right? But that is what I'm going to show you later lah, okay? So in general, to sketch a trigonometric graph, I would prefer to draw it in this way, which is starting from B, then A, and then C. And this BAC actually is from this equation, okay? So let's understand what does A, B, and C represent. Okay, so B here actually represents the total number of cycles that we need to draw within 360 degrees. Okay, so if we compare this equation with this equation, the value of B is 2. So this means we are going to draw the tangent graph 2 times, or 2 cycles, and all within 360 degrees. Right, so now I would draw here as a sketch first, then later on we will draw it into our graph. Okay, so I will just do a sketch first. Alright, so the first cycle of the tangent x graph will be something like this, and then the second cycle will be something like this. So everything is drawn within 360 degrees, or 2 pi. Alright, and now let's go to A. So A here represents the minimum or maximum value of the graph, right? So if we compare to this equation here, A is 1. But for tangent graph, it does not have minimum or maximum value. As you see in the graph here, this part, it can still extend upwards. This part, it still can extend downwards. So there is no minimum or maximum value for this graph. Okay, the maximum value can be infinity, the minimum value can be negative infinity. Okay, but what we do know from A is we can able to find the middle line of the graph, right? Because just now I've mentioned maximum is infinity, minimum is negative infinity, so the middle line here would be the 0, or the x-axis. Okay, so this is the x-axis and this is the middle line of the graph. Okay, and now before we go into C, if you look at the equation here, A and B is inside the modulus. So now we are going to deal with the modulus. Alright, so how are we going to do this is, for all the graph parts which are below the x-axis, which is all of these, okay, we are going to use x as the mirror to reflect all these parts upwards, okay, which is something like this. Okay, from here to here. Okay, I reflect all the parts which are below the x-axis upwards. Okay, so now you can see all the parts of the graph are all positive already, because all are above the x-axis. Alright, then later on we can go to C, which represents the axis of symmetry, which also what I've mentioned, the middle line of the graph. So now the C is 1, so means that the previous axis of symmetry here, I need to add 1. Okay, so when I change the axis of symmetry, this means I am moving the entire graph. Right? So just now it was 0, so if I change to 1, this means I'm moving the entire graph upwards by 1 unit. Okay? So now, once we have this already, then we can sketch it to our official graph. Alright, so we can put our graph here and label the axis of symmetry, and then we can able to label the x values lah, the important x values. For example, here is pi over 2, here is pi, here is 3 over 2 pi, and here is 2 pi. Okay, and for a tangent graph, we need to label the asymptotes. Right, so recall back, asymptotes are the parts where the graph cannot intersect those lines. Okay, so those lines are called asymptotes. Right, for example, these 4. Okay, so how do I find pi over 4? It's just to find the middle of 0 and pi over 2. For example, 3 over 4 pi, it's the middle of pi over 2 and pi. Alright? Okay, so now we have dealt with this modulus already, and yeah, this one. So we can only draw until pi, so the things after pi, we can just write it off. Alright, so this will be our answer. And for the last part, essentially is using the graph that we have drawn just now to solve some questions. Okay, so for part 1, it says that we need to find the suitable equation of straight line to find the solutions from this equation. Okay, so this question actually tells us to transform this equation in a way that it must have the y. Okay, so this y is from part B. So essentially, we need to transform this thing to become something like this, then only change it to y. And this y would be the suitable equation of straight line. Alright, so what we need to do now is for this part, which is very familiar because it's in part A, which is the thing we are proving just now. Right? So the things inside the modulus, we can change it to tan 2x. Okay, and if we look at the equation in part B, we have modulus tan 2x plus 1. So here we are missing with the plus 1, so we can move this negative 1 to the other side. Okay, so essentially, modulus tan 2x plus 1, we can change it to y. And here we can just put it down. So this will be our suitable straight line to find the number of solutions for this graph, okay, which is y equals to kx. And for part 2, it says that we need to find the range of values of k, so means there will be inequality, and it says that the straight line that we have gotten just now does not have any solution. Right, so what does this solution mean? Because we also see it in part 1. Right, so this actually means if we draw out this graph, right, if let's say k has a number, alright, and we draw out the line which is something like this. So here, if you see this red line and the graph that we have drawn just now, we have 3 intersection points, right? 1, 2, 3. So because the number of intersection points is 3, so means the number of solutions is 3. So essentially, solutions is the intersection points. Okay, so now it says does not have any solution. So this line cannot intersect with the graph that we have drawn just now. So we need to find all possible values of k that this happens. So I'll explain it in this way first because this application does not have the animation that I want. Alright, so if we go back to the line that we have, right, y equals to kx, there is no y-intercept, or meaning our y-intercept is 0. That's why the line starts here. Okay, so as you see, if I move the line, all these parts will intersect the line until I have gotten below here, right? As you can see now, the line does not intersect the graph. Okay, but the last part that this line intersect the graph is here, right? Which is at this part, the coordinate is pi 1. So if we can find out the gradient of this line, which it intersects the point of pi 1, then means the lines which have a gradient which is lesser than the previous line, it will not intersect the graph anymore, right? Okay, so what we need to do is, let's find the gradient first, okay, which we have done here. So if I substitute 1 and pi into the equation here, okay, then our k value is 1 over pi. So this k is actually our gradient lah. So this line, the gradient of this line is 1 over pi. So if it's lesser than this, then this means this line does not intersect the graph. So we can consider all the lines which satisfy this criteria. So our final answer would be k must be less than 1 over pi. For question 6 focuses on differentiation, so here we are given the equation of total surface area of a box, which is this one, and the value of x represents the length of the side of the box. Alright, so in part A, it says that when x equals to 3, there is a small change in x by 2%, and we need to find the percentage change for the total surface area. Right, so this actually relates to the last application of differentiation, which is the small changes and approximation. Alright, and in that section, we have two formulas. So the first one is delta y over delta x approximately equal to dy over dx. So this symbol is called delta, and delta represents small changes, right? So delta y will be small changes of y. And the second formula is if we want to find the percentage change in y, then it will be the delta y, the small change in y, divided by the original value of y. Okay, original. So now back to the question. To find percentage change in total surface area, we can use the second formula and we just adjust it in terms of total surface area. Right? So the delta y will become delta A and the y will become A. So essentially we need to find two things. Alright, so to find delta A, we can actually use the first formula. Alright, so the y here I will change it to A, but for the x I will remain because the equation here that is x. Right, and it's the only unknown that is related with A. Okay, so we can use this formula to help us, so we can move this delta x to the right side. So to find delta A, we need to get these two things first. Right, so this one is the differentiated equation of A, and this is the small change of x. Right, so to find this one, we just differentiate the original equation of A lah, which is taken from here. So the x, I move it on top, so here will become x to the power of minus 1. Alright, so to differentiate, we can just move the power to the front, so 2 times 2 will be equals to 4, and power minus 1. So here will be essentially 1 only, which is x lah. Okay, and the minus 1 multiply with 540, so it's negative 540, and the power I minus 1, so here is minus 2. Okay, and for delta x, actually we can find it from this clue here. It says a small change in x by 2%, so technically we can use the second formula. It's just that everything we change it to percentage change in x. Okay, so this part is given, so percentage change in x I already substituted with 2%. Okay, and the y here I will change to x, and here will be 100%. So this x will be the original value of x, which is 3. Okay, so I need to substitute this with 3. Okay, and then this 100 I move it to the left side, becomes 0.02, and then I multiply to get the delta x value, which is 0.06. So now with these two values, I can multiply them together. Okay, so here what I will do is for the x part, I need to use the original value of x, okay, which is x equals to 3 lah. Right, then I can get the delta A value, which is negative 2.88. So it's a decrease in total surface area lah. So now we have found delta A. Now we need to find the original value of A, which is quite straightforward. We just need to use the original equation here and use the original value of x to find the original value of A, which is 198. Okay, so once we have these two things, then we can apply everything into this formula. Alright, so 288 divided by 198, then we will find the percentage change, which is 1.455%. Alright, you will realize that I didn't put the negative here. So it didn't ask us to find the percentage increase or the percentage decrease in total surface area. It's just that we just need to find the change in the total surface area if we change the x by 2%. Okay, so it's just comparing the original value with the new value, how much does it change, without looking at whether it's increasing or decreasing. For part B, we need to find the value of x if the total surface area is maximum, right? So this actually applies to the second application in differentiation, which we learn how to find minimum or maximum points, right? So the first step is to differentiate the original equation, which we have already done here. Okay, so we can put it here. Okay, then the second step is we need to change the dA over dx to be 0. Alright, dA over dx to become 0, and here we just rearrange the equation a bit, make sure x is on the left side, okay, and then this cube we apply to the right side, then we'll get the value of x already, which is 5.13 cm. Question 7 focuses on circular measure and allow me to draw two lines in this diagram in this way, so to help you all understand this question easily lah. Okay, and then the intersection point here I'll label as E. Okay, so back to the statement here, we have two things to know. So the first thing is this DC is an arc of a quarter of a circle, right? So DC is here, so means that CED is a quarter of a circle, which means that this angle is a 90-degree angle. Alright? And another thing is the OD is the perpendicular bisector of chord AC. So OD is this line, AC is this line. So perpendicular bisector means this OD will split the AC by half, and the two halves have the same length, right? So for example, AE will be the same length as EC. And also it says that OA is equal to AC is equal to 6 cm. So OA here is actually the radius of this sector, OAC, right? So here will be 6, here will be 6 as well, right? And also this AC is also 6 cm, so just now we split it to half already, so if we split the 6, it will be 3. Okay, so in part A, we need to find the angle of AOC, which is here. Alright, so to find AOC, if you look closely, this angle is actually inside this triangle, OAC. Okay, this triangle. And if you realize, all the sides of this triangle is the same. So this means if all the lengths are the same, meaning all the angles in the triangle are the same. So we know that the total angle for a triangle is 180 degrees. So to find AOC, I just divide by the three similar angles here. So the angle should be 60. Okay, but here take note, yeah, it says in radian. So for the angle here, we need to multiply pi over 180 to get the radian, right? Which is 1.0473 radians, and make sure to put in 4 decimal places. For part B1, we need to find the perimeter of the shaded region, which is here. So we need to find the length of 3 lines, BC, CD, and BD, right? So let's start off with line BC, or arc BC. So since this is an arc, we can use the formula in this chapter, which is R multiplied with the theta, radius multiply the angle in radians. So going back here, this arc belongs to this sector OAC, and the radius here is 6, so let's multiply 6 first. Okay, and then the angle here, it should be from BOC. Okay, BOC is actually half of the angle that we have gotten just now, which is this 1.0473. So to find the half angle here, we just divide by 2, right? And then we multiply to get the length of arc BC. So this is the first side, and the second side is arc CD. So if we focus on the quarter of a circle here, the radius is 3 cm. Alright, and then the angle here is 90 degrees, but we need to change it to radian. Alright, so we need to multiply pi over 180 to get the radians. Alright, and then to get the length for arc CD. And for the last line, which is line BD, which I think this is a bit tricky, because here we know the radius of this circle, which is E to D. Okay, so to find BD, what we need to do is to find out BE, right? So 3 minus out BE, this small part here, to find BD. Okay, so now let's find the length BE. Okay, so BE we can use the sector to help us, right? So here what we can do is let's calculate the length of this whole line, which is from B to O. Okay, B to O, and then to find BE, I minus out the part that I don't want, which is EO. Okay, EO. So to find BE, BO, which is the whole line here, minus out EO, the part that I don't want. So BO here is actually the radius of this sector, which is 6, right? So this one settle. Then for EO, if you realize, it's actually part of this triangle OAE, right? OAE. So this is actually a right angle triangle, so we can use the Pythagoras theorem to help us. So here to find OE, it's just 6 square minus 3 square, and then we square root. Right? So with all of this here, then we can straight find the length of BD, which is 2.196 cm. Okay, so now we have the length of all 3 lines, then we can just add them up together to find the total perimeter, which is 10.051. And for the next part, we need to find the area of shaded region. So the shaded region is inside this quarter of a circle, and to find areas, usually I will use this technique, which is big shape minus out the small shape. Right? So big shape meaning I need to find a recognizable shape which includes the shaded region. So for example, this quarter of a circle, ECD. Okay, reason is because we have some certain formulas to help us find the quarter of a circle or area of a sector. Right? So I would select ECD. Then for the small shape, is the parts that I don't want in this big shape, which is here, ECB. So I need to find ways to remove out this part. Okay, so to find the area of shaded region would be ECD minus out ECB. Okay, so we need to find the areas of these two parts. So to find ECD, which is a sector of a circle, we can use the formula given in this chapter, which is 1 over 2 times r squared times theta. Right? So here will be 1 over 2 multiplied with the radius of the circle, which is 3. Okay, 3 square here, then multiply with the theta or the angle, which is 90 degrees, or in radians is 1.571, calculated in the previous part, which is in part B1. Okay, then I multiply to get the area of ECD. Right, but for ECB, we don't have a straightforward formula to help us calculate, so why not we use back the same technique, big shape minus out the small shape. Alright, so the big shape that I can recognize, which includes ECB, would be this part of a sector here, BOC. Okay, and then I minus out the part that I don't want, which is this triangle EOC. Okay, so to find ECB would be the sector minus the triangle here. Alright, so for finding the area of sector BOC, we can use this formula. So 1 over 2 multiply the radius of the sector of a circle, which is 6. Alright, and then I multiply with the angle, which is BOC, which we have also found in part B1, which is this value, okay, from this, and then I minus out the area of the triangle, so 1 over 2 times the height, which is 3, times times the base here. So base we have also found in part B1, which is square root 27 coming from this. Okay, so I simplify, then I can get my area. Okay, so once we have the two areas, then we can find the area of shaded region by minus these two together to get the answer, which is 5.437.